Hello everyone. In this video we will solve AP chemistry problems regarding colligative properties of solutions. First of all, what do you mean by colligative properties of solutions? These are properties that they depend on the ratio of number of mole of solute to the number of mole of solvent and not on the nature of the chemical species. When we add solute to a solvent, freezing point gets depressed. So the formula that we use is delta F freezing equal I Kf times M. I stands for the Van 't Hoff factor, which is the number of mole of ions in case we are dealing with ionic compounds. If the compound is molecule, so I will be equal to 1. M stands for the molar concentration of the solute, and Kf it's the constant. If I'm talking about freezing, so it will be the molar freezing point depression constant of the solvent. On the other way, if we are talking about boiling point, adding solute to solvent elevates the boiling point. So we talk about boiling point elevation. And the formula that we use, delta TB, the change of temperature boiling, equal I, again, the Van 't Hoff factor, times molality, molar concentration of the solute. But this time KB stands for boiling point elevation constant. So it's the molar boiling point elevation constant of the solvent. Based on this, let us start solving problems. The normal freezing point of water is 0 degrees Celsius. So if I'm talking about water pure, its freezing point is 0 degrees. So I start given T freezing for water pure equals 0.00 degrees Celsius. And its freezing point depression constant, so Kf is 1.86 degrees Celsius per mole. If we make up a 1 molar solution, so the molality is 1 mole of Na2SO4, what is the freezing point of the mixture? So we want to find the freezing point of the solution. Okay, so we will go with the formula. Delta T freezing equal I K freezing times molality. We have to know several things before solving the equation. First of all, delta T freezing, because freezing point gets depressed, so it will be T freezing of the solvent minus T freezing of the solution. Why? Because this quantity is less than this quantity. Secondly, I, as we said, is the Van 't Hoff factor, depends on the number of ions in case I'm talking and dealing with ionic compound. M stands for the molality, and the molality always equal the number of moles of solute over the mass of solvent expressed in kilogram. Okay, now let us go back. The solute I'm dealing with is sodium sulfate, which is ionic compound. So it separates and dissociates to give 2 Na plus ions plus sulfate ion. Sum up to 3 ions in total, which means I equal 3. Okay, so we write delta F equal 3 times K freezing, which is 1.86 times the number of mole of solute. He gave me already molality directly, so times 1. Okay, so delta T equals 5.58 degrees Celsius. Now let me find the TF of the solution. We know that delta T equal T freezing of the solvent, here water, minus T freezing of the solution, which is equal, as we calculated, 5.58 degrees Celsius. Just a simple substitution. Freezing point of water is 0 minus TF of the solution equal 5.58 degrees Celsius. So simply T freezing of the solution is minus 5.58 degrees Celsius, and this will be the answer for this problem. Now number 2, what is the normal boiling point of a 0.122 aqueous solution of potassium iodide? Again, the meaning of aqueous, it means that directly we know that the solvent I'm dealing with is water. Okay, let me start by listing the given and the requirement. We have molality 0.122 molal, and we have Kb, which is 0.512 degrees Celsius per molal. And we have to pay attention that potassium iodide is ionic compound that splits into ions, 1K plus and 1A minus, sum up to 2 ions. So I here equal to 2. Now the formula, delta T boiling equal I Kb boiling times the molality, which is equal to 2 times 0.512 times the molality 0.122, which is 0.125 degrees Celsius. But we know that delta T boiling equal, this time I start by T boiling of solution. Why? Because the boiling point gets elevated. So this value is higher than the T boiling of the solvent. In our case, solvent is water, equals 0.125 degrees Celsius. T boiling of the solution is the one that we need to calculate. The solvent, which is water, boils, pure water boils at 100. So the TB of the solution after finishing the calculation is 100.125 degrees Celsius. So this is the answer. Okay, now automotive antifreeze consists of ethylene glycol, a non-volatile, non-electrolyte substance. This info is very important. Non-electrolyte, it means I equal 1. It doesn't give ions. So calculate the boiling point and freezing point of 25 mass % solution of ethylene glycol in water. Okay, so we have to find the boiling point and freezing point. So TB of solution equal how much, and T freezing of the solution equal how much. Okay, solvent here in water, so solvent here is water, so I can use the constants for water that never changes. Constant molar boiling point elevation constant 0.512 degrees Celsius, and the Kf freezing for water equals 1.86 degrees Celsius per mole. These are the constants. Okay, I have 25 mass % solution of ethylene glycol. So I can say that let the mass total of the solution be 100 gram. If this is true, as we assumed, which is 100 gram, it means that the mass of ethylene glycol that have C2H6O2 equals 25 gram. From this information, I will be able to find the mass of water. So we say that the mass of the solution equal the mass of the solute plus the mass of the solvent. So the mass of the solvent equal mass of solution minus mass of solute, which is 100 minus 25, which is 75 grams. So the mass, the solvent here I'm dealing with is the water. This will help me in the molality later on. Okay, now apply. Let me start first of all by finding boiling point, and then I will move to freezing point. I can say delta T boiling equals I K boiling times the molality, which means that delta T boiling equals I is 1 because ethylene glycol It's a non-ionic. As you see, C2H6O2 is a molecule. It's not ionic. Constant boiling point constant 0.512, and molality, which is equal the number of mole of solute, which is the glycol. We have the mass given to us for glycol. I can find here its number of moles. So number of mole, it's the mass over molar mass. Okay, mass is given to me 25. If I calculate its molar mass is 62, which is equal 0.4 moles. So I can substitute here in the solution, which is equal 0.4 over the mass of water in kilogram. Mass of water is 75. If I divide by 1,000, it gives me the mass of water in kilogram, which is 75 times 10 negative 3 kilogram. So I will put it here. It will be 75 times 10 negative 3. So by the calculation, delta TB will be equal to 2.73 degrees Celsius. I can find now T boiling of the solution. Delta T equals T boiling of the solution minus T boiling of the solvent water, which is 2.73 degree. Okay, T boiling of the solution is my target. Boiling point of pure water is 100 degrees, equal 2.73. So the final answer and the T boiling of the solution will be 102.73 degrees Celsius. Like this, we found T boiling. Let us find T freezing. Delta T equal I KF times molarity. So delta T freezing equals, as we said, ethylene glycol is a molecule, so I is 1. Its K freezing is 1.86. The number of mole of solute we found at 0.4 over the mass of water in kilogram, which is 75 times 10 negative 3. And the answer for this will be 9.92. Okay, now we know that delta T freezing equal T freezing of the solvent, which is water, minus T freezing of the solution, which is 9.92. Okay, T freezing of pure water is 0, so 0 minus T freezing of the solution is 9.92, and the final answer, T freezing equal minus 9.92 degree Celsius. Like this, we found T boiling and T freezing. Now, okay, list the following aqueous solutions in order of their expected freezing points from lowest to highest. So we want to start from the lowest quantity to higher quantity, and these are the aqueous solutions. All of them, they are aqueous. In aqueous solutions, it means definitely that the solvent here is water. Because solvent is water, so K freezing is constant for all of them. I will start one by one. Calcium chloride, delta T freezing equal T freezing of the solvent 0 minus T freezing of the solution. Okay, which is equal for calcium chloride. Calcium chloride is an ionic compound, and it gives 1 calcium ion and 2 chloride ions, so I equal 3. So it will be I K freezing times molality, which is equal 3. KF, I will keep it as it is because it's constant for all, times the molality given, which is 0.05, and the answer will be 0.15 K freezing. This is for calcium chloride. Minus TF solution, so TF solution will be minus 0.15 times KF. Similarly, I will find for the rest. I will start NaCl. It's an ionic compound that splits into ions, Na plus and 1 Cl minus. So 2 ions, it's I equal to 2. So 0 minus Tf of the solution equal I, which is 2 multiplied by the molality and Kf, 0.15 times Kf. So it will be equal 0.3 and minus to the other side. So Tf solution for NaCl is negative 0.3 degree Kf. Okay, negative 0.3. Similarly, I will move and find for HCl 0.10 molal. HCl in water, it gives 2 ions, H plus and Cl minus, sum up to 2 ions, so I equal 2. So 0 minus Tf of solution equals 2. Its molality given 0.10, so 0.10 times Kf. So Tf solution of HCl equal negative 0.2 Kf. Kf. Okay. Similarly, I will find for the other one, which is HC2H3O2, the acetic acid. So acetic acid is a molecule, so it's I equal to 1. So 0, so I am talking about acetic acid, HC2H3O2. So 0 minus Tf of the solution equals 1 times Kf, and its molality 0.05. So Tf of the solution equals negative 0.05 Kf, and this is for acetic acid. Okay, the last one, which is C12 H22O11 0.10. Also this is sucrose, it's a molecule, so I equal 1. So 0 minus Tf of the solution equals 1 times 0.10 times Kf, which is equal 0 negative, okay, let us 0.10 Kf, which means Tf of the solution for the sucrose C12 H22O11 equals minus 0.10 Kf. Now I will compare which one is the smallest and which one is the largest, and I will start from the smallest. We have C12 H22 sucrose minus 0.1 10 Kf, here minus 0.05, minus 0.2, and minus 0.3, and minus 0.15. So the smallest one, it's for minus 0.3, followed by minus 0.2, followed by minus 0.1, then at last it's minus 0.005. Okay, so it will be the order like this: 0.05 molal of HC2H3O2 less than, definitely I'm talking in freezing point, 0.10 molal HCl, which is less than 0.05 molal calcium chloride, and less than 0.10 molal C12H22O11, and the last one 0.05 molal HC2H3O2. Okay, now number 5. A compound called pyrion has the empirical formula C8H5. Empirical formula, it means the simplest formula. Empirical means the simplest formula, which is not necessarily the true formula. So we need to pay attention for this, which is not necessary at all to be the true formula. When 4.04 gram of pyrion is dissolved in 10 gram of benzene, the boiling point of the solution 85.1 degrees Celsius. So this is T boiling for solution. This is the mass of benzene, which is the solvent, and he gave me the empirical formula. Calculate the molar mass of pyrene. So we need to find the molar mass of pyrene and determine its molecular formula. And he has given me the constant, molar boiling elevation point constant, and the T boiling for benzene. Okay, so the first requirement, calculate the molar mass. The second requirement, I need to find the molecular formula. Okay, let us start. Since I'm dealing with boiling, so delta T boiling equal I Kb times the molarity. Let me find what missing in order to fill up. I am dealing with pyrene, C and H, non-ionic, it's a molecule. So first of all, we know that I equal to 1. Molality, simply it's the number of mole of solute, which is the pyrene, over the mass of solvent, which is the benzene, in kilogram. Okay, let me find the number of mole of pyrene, and it was given to me its mass. So N equal mass over molar mass of pyrene. So it will be number of mole is 1 point. Okay, mass is what? Let me see. Let me recheck. 4.04 gram of pyrene. Okay, so the mass is 4.04. So we write 4.04 N equal 4.04 over the molar mass. Keep this in your mind. Let me keep the molality now alone, and then I will solve for it. Okay, I will substitute here delta TB, which is T boiling of the solution minus T boiling of the solvent, which is the benzene. Okay, T boiling of the solution, it's given to me 85.1, and that of pure benzene 80.1, which is equal to 5. Okay, so let me substitute in the equation. 5 equal 1 times Kb, and the Kb is given to me 2.53 multiplied by its molality. Okay, so the molality equals 5 over 2.53, which is 1.98, and the unit is molal. Now I can find the number of mole, because the molality simply it's the number of mole over the mass of benzene in kilograms. So it's the number of mole of pyrene. Okay, let me substitute for the molality, the one that I found, which is 1.98 equal the number of mole I need to find over the mass of benzene. It was given to me the mass of benzene to be 10 divided by 1,000, so 10 times 10 negative 3. So the number of mole after calculation 0.0198 moles. Okay, I will call this 1, so, and this is 2. I will substitute 2 in 1. So I say substitute 2 in 1. So N, which is 0.0198 equal 4.04 times the molar mass, which means times the molar mass, which means that the molar mass is 204 gram per mole. Okay, now we found the molar mass. Let us find the molecular formula. The rule to find the molecular formula, always the empirical formula multiplied by a number I don't know, I need to calculate, equal to the molar mass. And the molar mass already I found it, which is 204. Okay, let us continue. The empirical formula, it was given to us in the problem, C8H5 times N equal 204. Now the molar mass of C8H5 after calculating it by adding the atomic masses, we know that carbon is 12, hydrogen is 1, is equal to 101. So 101 and 1 N equal 204, which means N equal 204 over 101, approximately 2. This number that I found, I will multiply by the subscript of the empirical formula to get the molecular formula. So C8H5, I multiply all the subscript by 2. This is the number I found, and the molecular formula turns to be C16H10. Like this, we're done from this problem. The last problem in our session, we will talk about mass of calcium chloride, and we need to do some calculations. A mass of calcium chloride, when dissolved in 100 grams of water, so water is the solvent here, and calcium chloride here is our solute. Okay, so let me write the given. The mass of water, it's 100 grams, gives an expected freezing point, so T freezing of the solution equals -5 degrees Celsius. What mass of glucose? So the requirement, I need to find the mass of glucose would give the same result. Okay, first of all, let me work with calcium chloride, and then we will deal with glucose and finding the ratio in between them. Okay, let us say for calcium chloride, delta T freezing equal I times K freezing times molarity. Here we pay attention. Again, calcium chloride ionic compound, it gives ions in the solution, Ca2 plus and 2Cl minus. So 1 Ca2 plus 2 Cl minus sum up to I equal 3. Number of ions is 3. Okay, delta Tf is T freezing of the solution, of the solvent, minus T freezing of the solution equal IKF times molarity. Okay, the solvent is water, so freezing point of pure water is 0, minus TF of solution, okay, equal, no need for this because already he gave it to me. He told me that the freezing point, okay, it's -5. Yeah, I can, yeah. Okay, no need to write this directly, it's -5. Okay, equal I, which is 2, times K freezing. Speaking about water, we found, and we know from number 1 that the K freezing of water is 1.86 degrees Celsius per mole. Okay, so 2 times 1.86 times the molality. What is the molality? It's the number of mole of calcium chloride over the mass of water. Given mass of water in gram, I will divide it by 1,000. It will be 0.1 kilogram. Okay, 0.1 kilogram. So continue. 0 minus -5, so 5 equal 2 times 1.86 number of mole of calcium chloride over 0.1 kilogram. Like this, I will be able to calculate and find the number of mole of calcium chloride. So the number of mole of calcium chloride after calculation, it will be I equal 3. Sorry, here just I have to put 3. Okay, so it will be equal to 0.089 moles. Why I found the number of mole of calcium chloride? Because I need to relate it to the number of mole of glucose and then to find the mass of glucose that he asked for. Let us do comparison between calcium chloride and glucose, the one that I want to find its mass. Delta T freezing equal I K freezing times the molarity, which is the number of mole of calcium chloride over 10⁻1. Okay, over, let me divide because I am finding relation, equal I Kf times number of mole of glucose over 10⁻1. In comparison, I will be able to relate the relation between number of mole of calcium chloride and that of glucose. I in calcium chloride is 2, because 3, because as we said 3 ions. Here we have 1, because glucose is a molecule. It does not dissociate into ions, so it's 1. Delta freezing, it's the same. He said equal. We wanted to find the mass of glucose at equal conditions, so delta freezing 1 equal. And this will be 3. Both of them, they have solvent water, so which is 1 and 10 negative 1 and 10 negative 1. Like this, 1 equal 3 number of mole of calcium chloride over the number of mole of glucose, which tells me that the number of mole of glucose equal 3 times the number of mole of calcium chloride. Very good. So now I found already the number of mole of calcium chloride. Just I will multiply and find the number of mole of glucose. So number of mole of glucose, 3 times 0.089, which is 0.267. Now I can find the mass because I have the number of mole of glucose. So I will continue and find the mass. I will say, but N of glucose equal the mass of glucose over the molar mass of glucose. By the way, glucose, it has formula C6H12O6. So the mass, number of mole of glucose, we found it already. So I substitute 0.267 equal the mass of glucose over, if you find the molar mass by adding the atomic numbers, knowing that carbon 12, hydrogen 1, oxygen 16, you will find it 180. So mass of glucose is 180 times 0.267, which is 48.06 grams. Okay.